Oh man, and we're actually on time. We're starting it on time. Hi there, various Facebook pals. This is Aaron Freeman. Let me see here if I can get this shared with my own timeline. Hold one quick second. Let's see there. I couldn't do it before. But let me just say right now, and welcome to my dear good buddy, Bill Higgins. Bill Higgins is a physicist at Fermi Lab. And Bill, you're also tell us, you're a solar system ambassador.
I'm a volunteer in the NASA Solar System Ambassador Program.
So, that's pretty cool. What does that mean?
It means that I've told NASA that I'm willing to share the solar system with people. And I often give talks hither and yon in various cities, sometimes on various continents, just telling people about what NASA spacecraft have found on Mars, or what we know about Jupiter's atmosphere, or whatever.
Well, all right, so now we got coming up here on the 21st of August, the Great American Eclipse. Are you excited?
Yes.
And what about this? Well, first of all, I suppose we should both say, we have coming up the Great American Eclipse.
That's right.
I find it immensely. See, if you have yours on, I have no idea. Do you have yours on?
I have them on.
Oh, okay. I can't see it. That's really terrible.
I want to be able to see yourself in the reflection.
Yeah, I mean, something. I mean, it's really pathetic. It's really. I'm sure that on the 21st, I will be very happy that I have them. Or will you be down there in the swath that is cut by the path of totality?
I'm hoping to get down there, and I'm taking my chances. It might be cloudy. It might rain. And if it's cloudy, you're not going to see the total eclipse.
Well, but it'll still feel like it's night.
Yes, it'll get dark for a couple minutes under the path.
Yeah, okay. You won't get to see the disc coming in and all that. So one of the things, okay, we are on Facebook, and if any of our friends want to go to the C2ST website, you have to go to the C2ST website, Chicago Council on Science and Technology website on Facebook, and if you have questions for Bill Higgins about the eclipse, about the solar system, for which he is an ambassador, please come onto the C2ST Facebook page and join us. So, all right. So we wanted to talk about a little about the eclipses. So this is the first eclipse since 1979, but it won't.
Well, we should distinguish between total eclipses and other kinds of eclipses, and maybe between lunar eclipses and solar eclipses.
That's certainly true.
It's much more frequent that the moon passes through the shadow cast by the Earth, and suddenly the moon can't see the sun, and the moon goes dark. And this is a pretty frequent occurrence, and I think you have a good chance of seeing many total lunar eclipses in your lifetime. But it is less frequent that the moon, in its path as we see it pass through the sky, passes directly in front of the sun and blocks all the sunlight that we can see from the Earth. And when this happens, the total eclipse of complete darkness, where the moon completely hides the sun, only happens in a pretty narrow area. But there's partial eclipse far beyond that. For instance, on August 21st, there'll be a narrow path running from Oregon to South Carolina, where if you're within a few miles of that, you'll see a total eclipse. But almost all of North America will see at least a partial eclipse where, some piece of the moon passes in front of the sun, and some of the sunlight is left. And that's interesting too. But the totality is the coolest.
Well, now let's say, and where will you be?
I haven't figured it out yet. I'm still looking at maps and hunting my target.
Now, I want to say again, we are on C2ST's Facebook page, Chicago Council on Science and Technology. We would love to have your questions. After you type in a question on your own page, it won't work. But we need you to go to Chicago Council on Science and Technology's Facebook page, and you can type in your questions and ask questions. Let's see. So but
friends have recommended St. Genevieve, Missouri. Carbondale, as we mentioned, is going to be a big gathering point.
Well, we didn't actually mention the really fascinating thing about Carbondale. Please.
That's right. There is. I said total eclipses are pretty rare, and it's very, only a few times in a lifetime is one visible from your house. Well, there's another total eclipse coming to North America, a total solar eclipse in 2024, and when this happens, it will have a path of totality as well, and the path of totality crosses the path of totality of this one, and it crosses it near Carbondale, Illinois. So if you happen to have a house somewhere near Carbondale, you will get to see 2 eclipses in the next 7 years.
Now here, Sasha says that will the partial eclipse in Chicago still be spectacular? Will it?
I believe so, yeah.
Thank you very much, Sasha.
The majority of the moon will be cut off in Chicago, but it won't be total.
Well, so what does that mean? That mean will it get darker?
Yes. You might not even notice it getting darker because your eyes are very good at adapting to fairly low light conditions. Okay, so if, I don't know, half of the sunlight goes away or 90% of the sunlight goes away, well, that'll be like temporary dimming, like you often get from clouds passing in front of the sun. So if you didn't know there was a solar eclipse happening and you didn't happen to notice the shadow in front of the sun, then you might just think it was a normal day and maybe there's a cloud or something.
But if you have these, you will be able to look up into the sky and see the disk partially blocking the sun.
Yes. If you have glasses that are certified as safe for solar viewing, I'll remind you, you can actually watch the sun anytime with them, not just during an eclipse. And you might like to, if you have the glasses, to practice observing the sun on sunny days between now and August 21st, or on sunny days afterwards. Look for sunspots, get an interest in what the sun is doing.
You can see sunspots with these glasses?
Sunspots are pretty small, so probably depends on how good your vision is, I guess. But if there are big enough sunspots, you could probably see them with these glasses.
Would you be photographing these sunspots here with the eclipse here in Chicago?
I don't know. I think I'm going to improvise.
Okay, all right.
So, maybe at least during the moments of totality, I'll probably want to, observe the experience and take it in. Other people take the couple of minutes that this is going on, and they'll get ready for it and make incredible photographs, or even study the sun with other instruments and get make the most of the moment with their technical needs. But sometimes I've reached an age where maybe I don't want to take a whole lot of pictures. I just want to enjoy the experience.
Now, a solar eclipse was the cause of one of the great scientific confirmations of all time.
There's been a lot of important science that's been done during solar eclipses in the past. But the most famous eclipse of the 20th century was the eclipse of 1919. In the southern hemisphere, the path of totality went across the southern Atlantic, and some astronomers went out to various islands or South America and tried to take pictures of not only the sun, but when it got dark during the totality, they took pictures of the stars near the sun, because the sun is in space and there are stars behind it, right? And beside it, we just don't see them in the daytime. The reason these astronomers were doing this at this time was that a few years earlier, Albert Einstein had published his theory of general relativity.
Yep.
And the theory of general relativity is weird and interesting, but it's very powerful, and it makes certain predictions. One of the predictions is that gravity can bend light. Now, gravity can't bend light very much, and you have to have a lot of gravity even to get a small deflection in the path of a ray of light. But
we happen to have a bit of gravity producing matter in our solar system.
Well, the sun is the biggest collection of matter by far in our solar system. It's 1,000 times more massive than the next biggest object. So it is the right place to look to see if somehow starlight can get bent by the gravity of the sun. And so the astronomers who knew exactly what the position of the stars was in the normal sky when the sun didn't have to be passing through it, they could they went and they measured the position of the stars while the sun was there, and because the sky was momentarily dark, it offered an opportunity to take some photographic plates of the star position.
And it
proved that the starlight was deflected, and the stars weren't in the positions that you'd otherwise expect them to be in. They had moved a little bit because the path they took was somewhat bent and before it got to the telescope. And that proved that the gravity of the sun was deflecting light, and it was deflecting light by about the amount that Mr. Einstein predicted. And so this was an important test of whether general relativity was the right theory of gravity or not.
So now Jim Carr, let me just say, Jim, we got a question here from Jim Carr, and he wants to know, would the time frame for viewing the event what would be the time frame, and how long will it last? Thank you very much, Jim Carr.
Boy, I haven't memorized those numbers, Jim, but on Monday the 21st, the eclipse in Chicago starts at 11:54.
11:50 a.m. Now, I know the totality, the center of the totality, the longest it'll last will be 2 minutes and 40 seconds, and that'll be right down near where we're going to try to get near, which is probably going to involve one of the largest traffic jams in the history of the continental United States.
Yeah, that's probably true. But if Jim is in the Chicago area, he'll be watching a partial eclipse,
right?
And it will last considerable while. And I should have looked this up before we sat down, right? But it's something like an hour or two.
An hour or two?
The moon is moving across the sun and at a speed of 15 degrees an hour, and it's half a degree wide. So, yeah, I guess maybe. Now is not a good time to compute this in my head, but
okay,
it might be half an hour or 40 minutes or something.
So, but when the totality, its maximum, the apogee of the eclipse will be how long? 2 minutes?
Well, no, it'll be gradual. That it'll the shadow of the sun will overlap, or shadow of the moon will overlap the sun, but part of the sun will be peeking out, and so early on it'll be a little bit of moon, and then it'll be a lot of moon, and then it'll be a little moon again. The ancients used to say the dragon was eating the sun, right? And you'll see in Chicago, you'll see the dragon take a few bites out of the sun, but the sun will not entirely disappear.
No, we're on the Chicago Council on Science and Technology Facebook page, talking with Fermi Lab physicist Bill Higgins, my buddy, Mr. Beam Jockey on Twitter, at Mr. Beam Jockey. And Bill is also a NASA Solar System Ambassador, a NASA Solar System Ambassador. Any one of you could become a NASA Solar System Ambassador if
that's right.
So inclined and so passionate. So let's talk, speaking of the solar system, about eclipses on other planets. Because Earth is by far not the only planet that has eclipses. Now, So tell me a little about some of the eclipses out there in the solar system. My guess is that Jupiter, actually it's not a guess, I looked it up, but Jupiter has a whole bunch of them. But tell us about some of the other solar systems.
Well, Jupiter's got a lot of moons. So anytime a moon passes, some kind of satellite, a rock orbiting a planet passes between the planet and the sun, then a shadow will fall on the planet, right? It's
like putting your hand in front of a flashlight.
Yeah. Mm-hmm. I often demonstrate this kind of thing with a flashlight and an orange.
Okay.
So, for instance, there are pictures that Mars rovers have taken when the moon Phobos travels across the face of the sun as seen from Mars.
Ah,
okay, which is interesting. I certainly enjoyed looking at the photo, but Phobos is a tiny little moon, so even when this happens, it doesn't cover the entire face of the sun, so it's not a spectacular event. It's just, oh, look, there's a shadow on the sun. The landscape on Mars won't get really dark when this happens.
Of course, it never gets all that bright on Mars anyway, because the sun is pretty small.
I suppose so, but that effect is more dramatic further out in the solar system.
Where?
Well,
what do you mean?
Anywhere further away than Mars, the sun will be dimmer.
Oh, well, that's true.
Now, Jupiter's got some pretty big moons, and we can often see in pictures of Jupiter the shadows of the big Galilean satellites falling on Jupiter. So you'll see Jupiter, let's say a nice picture of Jupiter that often has a little moon nearby, but then a big black spot, actually a small black spot somewhere on the face of Jupiter. That's the face of the moon. So if you were on Jupiter at that spot and looking up, you would see the sun get blotted out temporarily.
That's fun.
And given that Jupiter has, I don't know, like 60-something moons and old Saturn has a whole bunch too. There are at least little eclipses happening probably pretty often somewhere in the solar system.
Although it's fair to say you really couldn't watch the eclipse from the surface of Jupiter.
No, because there's no surface of Jupiter.
You see there, you knew that was going to be a problem. I knew that was going to be a problem.
You could be flying around in the atmosphere of Jupiter perfectly.
Now, is it true that NASA will have a plane flying around chasing this eclipse?
Yes. They're going to load up a couple planes with instruments and fly along the path of the eclipse, hoping to prolong the totality somewhat, so the instruments can get a better look at the phenomena they're checking out.
Was there any doubt that they can do it?
No, not really. It's pretty straightforward.
We got a question from Cody. Cody wants to know how will wildlife react to the eclipse? Because for them, they really will quickly think it is nighttime.
It'll be exactly like nighttime for a couple minutes under the path of totality.
We'll hear some crickets, maybe some crickets going, maybe some birds singing.
Oh, let me start by saying I don't really know the answer to this question. Okay. It's an interesting question, but I don't know anything about this. About this topic. However, it's a few minutes that it gets real dark, and it's maybe a somewhat longer period where lighting is dim in the landscape, and I just don't think that wildlife will adapt. Well, I think they'll adapt just fine. They've been on this planet as long as we have, if not longer, and they probably know what to do during an eclipse.
I wonder if anybody out there knows, anyone watching knows this. I'd love to know, will raccoons, will nocturnal hunters show up? Will the mice come out? Well, we know the mice will come out because we have with friends who are having a mice problem, and maybe the mice will come out and get into the traps during the eclipse. Maybe they're not really smart.
Where will nocturnal animals suddenly? That's intriguing. Will the deer come out for a while? Or?
Yeah. I mean, I'm sure that somewhere out there's some wildlife specialist, some expert from the Chicago Botanic Gardens or from Lincoln Park Zoo that could tell us that if they weren't working at 4:00 in the afternoon.
Yeah. Let us know if you've got a clue about this.
Well, look, actually, though I know you do have an actual job because you are at Fermi Lab and you've sequestered a room from Fermi Lab just to talk with us. And I really appreciate it very much, my buddy. So now, Bill Higgins, as I say, you've been watching the Chicago Council on Science and Technology. You are on our Facebook page, or this broadcast emanates from our Facebook page. We've been talking with our very, very dear friend, one of the absolute favorite geeks of my entire life, Bill Higgins, who is not just a physicist at Fermi Lab, but he is a volunteer in NASA's Solar System Ambassador Program. Bill, thank you immensely, gigantically, eclipsically much.
Yeah, it's my pleasure, Aaron, and it's always great to get together with you.
Well, let's do it again soon, brother. And by the way, you were the first guest, the initial guest, the inaugural guest for C2ST's Facebook broadcast. So thank you very much. You got our proverbial telephonic cherry, so to speak.
Okay. Everybody get your certified safe Eclipse glasses. You still got about 10 days to obtain them. And,
all right. Thank you.
Enjoy the eclipse.
All right. And to go to c2st.org and C2ST on Facebook.